Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, it's our honor today to have Doug Lynette visit us. Doug was in town for the Vanguard meetings, and we thought we'd have him here to update us on his 22-year project. Doug is one of the most passionate people I know in the AI community in terms of pursuing the prospect of endowing machines with common sense, one of the hardest problems we know in artificial intelligence. Doug did his PhD work at Stanford, and in that work, which was quite compelling, he showed examples of systems that might one day become commonplace, that could think about mathematical conjectures and go out and prove them, and even have inside their representations and reasoning notions of interestingness. But I always thought it was a fascinating pursuit. I often define people by what they think is interesting. Doug is now skipping ahead many years, is now the CEO, and I would say CTO probably, and many other positions at Cyc Corp, a corporation that had some foundations in the MCC early work on Cyc, and will tell us about where we stand on combining manually edited as well as machine learned knowledge bases that can perform common sense reasoning.
Thank you, Eric. I appreciate it. Okay, good. So I wanted to talk to you about the relationship between computers and common sense, which, as the title indicates, is historically and pretty much still today a kind of adversarial relationship, much more than it should be. And when we talk about common sense, when we talk about Cyc, we're talking about the millions of things that you know about the world that you pretty much assume that everybody sitting next to you would know about the world. Things which, if they didn't know, you'd think that they were sort of either joking or insane or something like that. Things like, hearts are usually on the inside of the body, and if you have feathers, feathers are on the outside of the body. And so, if you see a picture of a bird, there's a good chance that unless the bird's in bad shape, you're going to see the feathers and you're not going to see the heart of the bird, and things like that. And causes precede effects, and all the specializations of these things. So, for example, parents are generally older than their children is a special case of causes preceding effects, and so on. Most people in modern Western cultures smile when they become happy. So again, a lot of the knowledge is going to end up being culture-specific or temporally contextualized, and so on. We're not talking about things which are absolutely monotonically, monolithically true over all times and space and context. So there are millions of these pieces of information, and we've represented them in a form that computers can actually do something with other than just remember them and store them and parrot them back to human beings. And kicking and screaming, we've basically been forced to develop a more and more formal, more and more predicate calculus-like representation over the years, over the decades for that. When I say that the knowledge is almost completely language independent, what I mean is that while the system knows things like penitentiaries are much larger than writing pens, that knowledge has to do with the concepts of penitentiary and writing pen, not with the fact that in English you might happen to use the English word pen to refer to both of those meanings. So yes, it's good to have a lexicon and to know what the denotations of words are, but the actual underlying knowledge is independent of language. And yes, we have an inference engine to do automated reasoning. And yes, we have interfaces to communicate with other programs and so on. But by and large, the most valuable part of what we've done over the last 22 years is working out the ontology of hundreds of thousands of terms, and sitting on top of that skeleton, the flesh, the millions of axioms that define and constrain and interrelate those hundreds of thousands of general terms. I talked in my abstract about the semantic web, And in a way, the history of the semantic web is the history of a series of false peaks. People being optimistic that if only they could agree on X, surely computers could interchange their information and arbitrary machine intelligence would ensue. And way back, that was sort of at the level of agreeing on ASCII character sets or Unicode character sets and so on. Today, the Web 2.0 people make a big deal about agreeing on bags of XML terms. The problem is that if you talk to 27 different companies, while you can get them all to use /employee to mean employee, they're going to mean 27 very slightly different things by what is and is not an employee. Do you consider consultants employees, seasonal employees, temporary employees, and so on? Or what it means to be a /company vehicle. Are your forklifts company vehicles? Now, if all you're doing is information retrieval, then those little tiny semantic divergences, those little tiny semantic mismatches won't matter too much. But if you really are asking questions that require arithmetically or logically combining pieces of information from 2 or 3 or 7 different sources, then those little tiny mismatches will combine to very often give you a genuinely wrong answer. So that's why those of you may have noticed the article in the New York Times that John Markoff wrote in which he sort of announced Web 3.0, which I guess means it's we'll have to start calling it that from now on. But basically, what you might call the real semantic web will basically have to go beyond that agreement on bags of XML terms. We'll have to agree on most of the meaning of most of those terms expressed in some more or less formal fashion. And we'll also have to agree on much more sophisticated and much more extensive sorts of metadata, not just the time at which something was entered on the web or the source or provenance, but also more semantic metadata attributes like who believes this to be true, when was it believed to be true, how certain is it, what's its epistemological status, and so on. So until we agree on the content and the context, we're only going to have a false peak for the semantic web. So as Eric and I have both mentioned, this has been going on a long time, our effort to build the Cyc inference system and knowledge base. The motive for this was pretty much that we kept hitting a brick wall. People like Bob Bowles doing robotics research back at Stanford when I was there, and in natural language understanding and speech understanding in expert systems, we kept hitting the very same brick wall, which is we'd build these systems, and they'd have wonderful properties in the small. We'd have wonderful little demos, and they just wouldn't quite scale up. And they wouldn't scale up because they didn't really have common sense. And so they'd work for their little demo areas, but then whenever we tried to apply them in ways that were not quite preconceived, there'd be 1 or 2 or 3 random pieces of information that they would lack that would keep them from succeeding in this new situation. And integrated out over all the new possible situations, what that means is that there are these millions of little tiny mattresses in the road that need to be cleared out of the way if you're really going to ever have machine intelligence. So about 1983, I and a few other people, Alan Kay and Marvin Minsky and Ed Feigenbaum, all started saying the same thing, that somebody needs to codify all this general knowledge. About that time, we actually had the means for the first time. America was scared to death of the Japanese 5th-generation computing effort. Japan had threatened to do in software and hardware what they'd already done in consumer electronics and the automotive industry, namely wrest control away from the US once and for all. And so the Justice Department granted a dispensation to the antitrust laws to large American companies to come together and form a consortium, MCC, which Admiral Bobby Inman formed in Austin, Texas, which is pretty much why I live in Austin, Texas today. So he came to see me. I'd been a Stanford professor for a long time, and he said, look, if you're really serious about this mattress in the road problem, it's going to take, 1,000-person years of effort to solve. You've got how many graduate students? 6? You do the math. Do you want to spend the next 200 years here as a professor, or do you want to move to the wilds of Austin, Texas, and possibly live to see the end of this project? So it was a close decision, but in the end, I chose to move to Austin. And to make a long story short, that's pretty much what we've been working on for the last 20 years. We've just about spent our 1,000-person years of effort. For those of you just tuning in to this effort, the good news is that by having skipped the first 22 years, you sort of tuned in at the exciting part of the movie. Our motivation was, as I mentioned, that software used to be incredibly brittle. We had lots of examples, and in honor of Eric, I have some old medical expert system examples of things like, this is actually not one of your systems. This was Alain Bonnet's skin disease diagnosis system, where we tell it about my rusted out old Pontiac, and it would ask questions, like, are there spots on the body? Yes. What color? Reddish brown. More on the trunk than elsewhere? No. And it would diagnose it as having measles. Or John McCarthy once asked the Myson program about someone who'd been dead for a week, and it, blithely diagnosed what kind of meningitis they should be treated for, and that kind of thing. So
John was complaining to me that he typed in "I am sick" to Myson, and was very upset when it gets the error message back.
Yeah, so there's all sorts of, right, exactly, all sorts of brittlenesses like that. Or there was a Fortune article about a car loan approval system that granted a loan for someone who said they'd been born in 1980, but they'd also worked at their current job for 29 years. So they're mistakes which no human would make if they gave it even a modicum of thought, but which computers make because they happen not to know some particular piece of information. Like, for instance, it's better to run over a dog than seriously injure a child. That's the kind of piece of knowledge which many of you who've watched Stanley Kubrick and Arthur C. Clarke's 2001, A Space Odyssey, a lot of people didn't understand why HAL, the computer HAL, killed the crew on the spaceship. But it basically was exactly that kind of ignorance where Hal had been ordered never to lie to the crew, but Hal had also been told on this particular mission he had to lie to the crew and keep the details of the mission secret. And so Hal found this elegant solution, which was to kill the crew. Then he didn't have to lie to them, didn't have to not lie to them. That's because nobody ever told Hal that it's better to lie to somebody than to kill them. So basically, it's now decades later, but software is still brittle. If I go to the web and I want to find out if the Eiffel Tower is taller than the Space Needle, I can't just type in the question. If I want to find out what PG-rated movies I could take my kid to that start in about an hour, not too far from here, it's annoying that I can't just ask questions like this. And if you go to Google and type that in, basically you get pages from which you could calculate the answer, pages which you have to ignore, because it turns out some of them deal with replicas of these items in Las Vegas, which have heights that are obviously different than the originals and so on. And yes, of course, if you do arithmetic, then you can find the height of the Eiffel Tower. You can find the height of the Space Needle. You can do the subtraction and figure out how much taller one is than the other. But why should we, as human beings, have to go to these different sites and do this arithmetic ourselves? So there are lots of missed opportunities by not understanding what the pages say, not understanding what the user is really saying, not being able to combine logically and arithmetically pieces of information from 2 or 3 of these pages, even in something as simple as the heights of the 2 buildings. And there's a real danger in giving power to computers, which we're doing more and more and more every day, in areas where basically we wouldn't trust human idiot savants, like, for instance, treating our children medically. Or there's always this talk, every 10 years or so, there's this craze about how home robots are just around the corner. They're going to mind the baby. They're going to cook meals. They're going to mow the lawn and everything. And then it never really materializes because, of course, without common sense, the robots would just as blithely mow the baby because they don't know, they don't care. They don't have common sense. They don't know that one is a bad thing to do. Basically, our software today has the veneer of intelligence, but without actual intelligence behind it, which is a very dangerous situation, just like if you have human beings that you know who have the veneer of intelligence, and that's all, it's really dangerous to give them a lot of power. I could give you examples, but I'm sure you could think of your own right now. So in terms of software, the example that I've used for decades, and it's still a fine example of what I mean by the veneer of intelligence, is the ELIZA, or doctor program that Joe Weizenbaum did at MIT 40 years ago, based on Rogerian psychiatry, parroting back, reflecting back what you say to it. So you say, I'm trying to smoke, I'm trying to quit smoking, and it says, tell me more about the fact that you're trying to quit smoking, or something. So in this case, you're saying to the system, my dog's mother died recently, and the system says back, tell me more about your mother, which sounds like a really deep psychiatric insight, but it's mostly unless you don't know how programs work. In this case, it simply doesn't know the word dog, so it sort of heard blah, 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 mother, and it said, tell me more about your mother. It's a lot like the Gary Larson Far Side cartoon of what you say to the dog and what the dog actually hears. And for those of you that are dog people, I will show you the rarely seen cat version of this cartoon of what you say to the cat and what the cat hears. But anyway, so yeah, that was 40 years ago, but surely things are a lot better now. It's 40 years later. And yet, if you look at the Turing test competitions, the Loebner competitions, the winners, by and large, are these little chatbots like Alice, where you say things like this, and it gives you this horrible, in this case, garbled, Eliza-like parroting back of what you said to it. Or where's Sue's nose when Sue's in her house? And it says, where it belongs. Now, this is actually not a bad answer, but it ruins it by going on and saying, try searching the World Wide Web. So obviously, it's just matching questions like, where is X or something like that. If you go to Ask Jeeves, again, you basically get the same results you'd expect from a site like Lycos or Google, namely some Boolean combination of keywords, in this case just a bag of keywords, and that's about it. If you go to Encarta, it's sort of strange. You get 2 hits, one on the history of automobiles, and one, I guess because of some kind of capitalization misunderstanding, on the Central African Republic. But anyway, you don't actually get the answer to your question because it doesn't really understand what the question is. And obviously, if you go to Google, you don't get a good result either because it's just taking those as a bag of words to search on. So the basic idea here is that we want the computer to understand, not just appear to remember information. And understanding means having the ability to reason and conclude the same sorts of deductive conclusions that you or I would from the information that it's been told that it could combine. So, all right, so why don't we just tell it the millions of things we need to tell it about the world we live in? And in fact, if you're not careful, you sort of fall into the obvious trap of, let's tell it that in English. And that ought to be relatively fast. Not very fast, because most of this is stuff that we learn by the time we're about 2 or 3 years old, and generally isn't written down anywhere. In fact, if you go to the web, often you find the negation of the things that people know about the world. Like if you look for hits on water flowing uphill and water flowing downhill, there are a lot more occurrences of water flowing uphill on the web because it's a metaphorical, dramatic statement. Everybody knows that water flows downhill. You don't have to say that to people, and so on. So there's a lot of times that you find wrong information out there. But even so, stating it in English is not really going to do the trick, basically, because while here we appear to have told the system about microwave ovens and dishwashers, in reality, even though you know what those words mean, if this is all we've told the system, it has no idea what these things are. It has no idea how microwaves are different from dishwashers. We might have used made-up words like this, and if I had used this on the slide, you wouldn't have known which was which either. Yeah, we go on and we have to state additional information, like the first one requires electricity and the second requires electricity and water. But again, we have to sort of axiomatize electricity and water and tell things like water comes to your house in pipes in liquid form. And even relationships like requires have to be axiomatized. So if an item, a device requires some resource and it doesn't have it, then it's going to stop functioning, that kind of axiom and so on. So the idea is that eventually, if you keep this up for year after year, decade after decade, millions of times, eventually there's just one interpretation that satisfies all those axioms, and it's the one where BuzzQua is water and get the whatever is microwave oven and so on. And if you keep on doing this, you can begin to trust the conclusions that the system puts out as being likely to be true in the real world. So I'll give you some examples now and at the very end of how this might actually affect your life, and both in terms of the applications you run and the applications you guys develop as well. But in terms of just information retrieval, finding information out there, here's a simple example of a system that we did several years ago for finding captioned images. Captioned images are good because the captions, the actual documents, are very short. They may be only 5 or 10 words long. And so if the caption is short, you can't count on the document to contain exactly the same words that your query is going to contain. So for example, in this case, you know that there's a match, and the Cyc system knows there's a match because of a few pieces of common sense, like parents love their children, and if somebody you love accomplishes something, it makes you happy, and if you're happy, you smile, and taking your first step is an accomplishment. So if you know those 4 things, then finding this match is trivial. If you don't know those 4 things, finding this match is basically impossible. And that's really the trick. That's really the secret of what we're doing, is sort of using general knowledge to convert impossible problems into trivial ones. Here's another example where it's finding a match between this caption and the query for pictures of strong and adventurous people, because it knows that if you're doing rock climbing, you must be at least moderately strong and moderately adventurous. So we're not talking about beating Kasparov at chess. We're not talking about 37 deep reasoning. This is like 1 or 2-step reasoning. If you have this knowledge, finding this match is easy. If you don't have the piece of knowledge, it's pretty much impossible. It's not like Google could add 15,000 servers tomorrow and find this match when they didn't find it today. If they don't have the piece of knowledge, they're never going to find it. There's nothing special about captioned images. This is from a more recent intelligence agency application we're doing, where the documents are having to do with terrorist incidents. And in this case, the question was about government buildings damaged in terrorist events in Beirut. And you have to know things like embassies are government buildings, and if there was a pipe bombing, then presumably there was some damage that was done, and so on. So again, domain-dependent, or in some cases very domain-dependent, knowledge might actually be required. There's also the same kind of knowledge required to do consistency checking, like noticing in this employee spreadsheet, HR spreadsheet, that this person seems to have been hired before they were born, and it looks like they listed themselves as their own emergency contact, and so on. So these things don't violate so much the schema of the database or the schema of the spreadsheet as they violate common sense. And you could say, well, why wasn't it the obligation of whoever put this together to have thought of all of those different constraints and written them down? Well, in reality, there aren't 8 columns, there are 80,000. And they're not spread out in one table. They're spread out in thousands of tables, in hundreds of databases out there on the web. And it's only because you happen to know what these column names mean, or can figure out what the column names mean, that you realize that some of these constraints should hold. So the basic idea then is that by having lots of knowledge in machine manipulable form, our programs could actually go beyond just the veneer of intelligence. I could give you lots of examples, but I'm going to pick a few examples just to illustrate this from natural language understanding, from disambiguating polysemous words and pronoun references and things like that. A lot of these examples are 20, 30, 40 years old. So this is not like new examples. These are things that people have known are problems for a long time. And it's very hard to see how to fix this if you don't actually have pieces of knowledge like how big things are to decide what kind of pen you're actually talking about in each case. Or an old Terry Winograd example, the police watched the demonstrators because they feared violence versus because they advocated violence. One of the theys is going to be the police, and one of the theys is going to be the demonstrators, and so on. Or if I say Mary and Sue are sisters, you assume I mean they're each other's sisters because so many people have siblings that if I really meant they each just happened to have a sibling, that would be a misleading thing for me to say. On the other hand, if instead I had said Mary and Sue are mothers, it would never cross your mind for a second that they were each other's mothers. And that has nothing to do with like linguistic theory exactly. It's sort of your knowledge of biological reproduction and what's possible, and back to this piece of knowledge about causes have to precede effects and so on. Every American has a mother. It's not the same mother, but it is the same president. John saw his brother skiing on TV. The fool didn't have a coat on. Presumably the fool is the person skiing. But if I had said the fool didn't recognize him, the fool would presumably have been John, the person watching television. So again, it's your knowledge of television and skiing and weather and stuff like that that enables you to answer these kinds of due to these kinds of disambiguations. So basically, we're talking about having a large corpus of knowledge and representing it in some formal fashion. We can refer to the words as the ontology if we want to be fancy. We can talk about this as being a formal ontology, which means that we actually have a whole bunch of these axioms or rules stated in a formal logical language. But the reason for using an ontology is the same reason for using any kind of hierarchy. For one thing, it helps you focus where information applies. So it applies to a node and its specializations. It helps you position new information. So if you know that water vehicles slow down in bad weather, you look around at the ontology and you say, well, that really applies more to surface water vehicles and really applies to surface vehicles in general. So even though you didn't have trucks in mind when you wrote the rule, that rule now applies to that truck, and you would predict that that truck would slow down in bad weather. And I think most of you in this audience are sophisticated enough to know what I mean when I say represented in logic, namely have some formal language from which we could conclude the same sorts of deductions that you or I would conclude. For instance, from Socrates being a man and men being mortal, conclude things like Socrates is mortal. Or one of my favorite examples that most of the people at Cyc don't like as much as I do, but is can, just to illustrate that this has nothing to do with natural language, because the internal representation, I'll switch to an English paraphrased version, basically has nothing to do with the English word can or can or whatever, because by the time the system reasons with them, those ambiguities have been taken away, and there's a unique way of representing can dancing and so on. By the way, the argument here is that cans can't do can dancing because they're inanimate objects, and can dancing pretty much requires having a brain as well as a body and so on. I could give some examples from some of our earlier systems in terms of the reasoning that they did that involve combining pieces of information from lots of different sources. So I'll give you one example. This is a project we did for DARPA several years ago. Basically, in this case, intelligence analysts were asking questions like, if because of some blockade, only Saudi oil is allowed to transit the Bab el-Mandeb Strait, could OPEC make up the supply loss to the world by snapping its fingers and increasing its production without actually having to build new production capacity? And in this case, the programs mostly said, and the experts mostly said, I don't know, because the countries keep secret the amount of oil they ship through the strait. But Cyc was able to give the answer yes, and when asked why, it basically combined information from about half a dozen different places. So from one place it found out the total amount of oil flowing through the strait, so the amount of Saudi oil and non-Saudi oil has to be somewhere in the range of 0 to 3.4 million barrels a day. From another place it found out what OPEC could have produced if it had wanted to during that year, and from another place it found out what OPEC was actually producing. So if you subtract those last two numbers, you find out how much OPEC could have increased its production by if it had wanted to. So it doesn't really matter what this number over here is. It's smaller than this number over here, so the answer is yes. And there were a lot of cases like that where the expert looked at the answer and the justification and said, oh yes, it's obvious that's the right answer. There are also a lot of cases where it got the answer wrong, but we don't have time to go through any of those cases. But it's not, it's like the dancing bear. It's not so much that it's doing a great job, it's that it ever works that's sort of impressive here. So nowadays we have an application called the Analyst Knowledge Base, and we're having a little bit of audiovisual trouble in terms of projecting it, but I have it running up here, and so afterwards, if some of you are interested, we could try to ask it some questions. But a lot of our funding these days comes from the Department of Defense and from the Office of the DNI and from intelligence agencies. So a lot of Cyc's expertise now in terms of outside of common sense, what domains is it been populated with, a lot of that expertise is in the areas of terrorism and counterterrorism detailed knowledge. So a lot of the questions, the hard questions that it can answer these days have to do with possible terrorist attacks and thwarting those. But basically, there are things like if you ask who had a motive for assassinating Rafik Hariri, the former Lebanese prime minister, basically, after a minute or so, you can get the question asked of the system, and it comes back with several surprising answers, like Israel and the U.S., but if you look at the source icons, you can basically see that it's some Al Jazeera editorial which is actually accusing the U.S. and Israel of colluding to assassinate Hariri. Now, on the one hand, you don't want to believe that without listing the source icons. On the other hand, you don't want to just ignore that, since there are millions of people in the world who do believe that to be true, which is why it's important to contextualize these by explicitly having the sources and possibly ordering this by source and so on. There's also information that Western analysts would agree on, which is that Syria was probably at fault here. And if you ask why, it says that it's speculative because there's a clause in the justification that it's not 100% sure of. And so you could say, yes, this is true, or no, it's not true, or I don't know whether it's true or not. If you say, I don't know whether it's true or not, then it'll generate a web query and go out and help you find the information from which you could actually answer the question. So one of the applications that we have of Cyc nowadays is the kind of semantic searching, where you put in a query, and it finds hits more sort of better in a little way than just syntactically pulling together bags of keywords. In this case, you've asked it about the Faithful Resistance, which it recognizes to be a terrorist organization. And so it's found some hits that mention Mustafa Durrani, even if they don't mention the actual organization Faithful Resistance, because he's best known as the head of Faithful Resistance. And conversely, it's eliminated an awful lot of web pages if you just do a plain old Lucene search. It's eliminated all these spurious web pages that just happen to mention the words Faithful Resistance, which are not actually talking about the terrorist group at all. So you end up with less false positives, less false negatives by doing this kind of simple ontologically aligned searching. So you could think of everything we just talked about in terms of question answering and so on as sort of fitting in a band between the typing in a question and the normal sort of hits you would get from some search engine. So that's sort of the way that we envision this being used. We also do semantic knowledge source integration of databases and websites and other structured sources using Cyc as a kind of interlingua. If you're not careful, you end up with a kind of n-squared problem in integrating information from multiple sources. Here we have different databases with different information about individuals. And if you ask how different in age were Qusay and Uday Hussein, neither of these databases can answer that question. But you as a human being, using knowledge of things like things age 1 year per year and so on, and Cyc, which also knows that, can answer the question by doing some arithmetic, and basically you come up with the fact that they were 2 years apart. You can also do something cool, which is you can put in 1966 there with the justification of this number 30 here, and you can put a 32 here with the justification of this number 1964 here. And if you want, you can even then throw Cyc away and basically be left simply with enriched databases at the end. Enriched knowledge sources. So that's sort of a cool thing, and we're doing that for various applications. One recent one involved sort of possible sites for terrorist attacks by pulling together knowledge of weather and susceptibility to various sorts of attacks, severity based on accessibility of hospital beds in the area, and so on. So here's a case where, among other things, the system had to figure out which cities in the US had population over 1 million. These are the same 4 rows just spread out because I didn't have room to put them all here. So this is basically saying Dallas has 1.02 million people. And in order to get this to work, we have to write rules in the system, assertions that explain the meaning of the the elements of that schema. So there's, for instance, this assertion which says that the population field of that table, of that database, contains the number of inhabitants of, well, the number of inhabitants of what? The number of inhabitants of the referent of the row of that database. And very often, this turned out to be a concept it took us a while to actually work out as being important and actually very commonly useful, which is the very existence of a row in that table means there is some geopolitical entity somewhere. And so it's referring to a geopolitical entity. So it's referring to something. And so it's that thing that is represented by the existence of the row, which has the population 1.02 million people and so on. Other assertions having to do with protocols for accessing it. Other assertions which tell you that this is a really good table to use. Other assertions which tell you statistically how many things you would get if you were to ask for them, like, for instance, how many named objects are there typically if you're given a county and a state, how many named objects do you have the longitude and latitude for? The answer here in this table is about 530. Or if you just ask how many different entries are there in the state column, well, you might think there should be 50, but in fact there are 60, probably because there are things like equivalents of don't know and District of Columbia and stuff like that. By the way, in case you wondered, the lucky winner was Phoenix, basically because they had a lot of people and they were warm enough for the spores to germinate, and they had a lot of suitable zoonotic hosts, and they didn't have a lot of hospital beds. And if you ask things like, why wasn't Philadelphia the lucky winner, it would say, well, it was too cold the day you asked, and so on. So overall, we have our axioms divided up into contexts by granularity, by time, by space, by culture, and so on. And while there is a single reasoning mechanism which would work, namely theorem proving, in reality, in pragmatic terms, that's too slow. If you're ever doing theorem proving, it's sort of like calling on the kid in the back of the room who always has his hand up or something. You don't really want to do that unless you have to, because you just know you're going to be sorry if you do. And it's sort of the same thing here, where we now have over 1,000 specialized reasoning mechanisms, and we try to call on the most efficient one that raises its hand, and only if we have to sort of grit our teeth and call on general theorem proving. Almost all the knowledge is non-monotonic. Almost nothing that you know about the world is absolutely true. Almost all of it is only true in some context. Like, remember what we said about Rafiq Hariri, or even something like each person has a mother who's also a person. It doesn't matter whether you believe in evolution or creationism. You believe there have only been a finite number of people. So it can't be the case that each person had a mother who was also a person. So almost everything you know outside of mathematics is really just approximately or usually true, or true by default. So by and large, the system reasons by argumentation, by gathering up the pro and con arguments and deciding which ones to believe, which ones outweigh the others. Although I've mentioned a couple times the number of concepts and the number of assertions or rules in our system, you should take that with a big grain of salt. We go out of our way to make those numbers as small as possible, not as large as possible. If you ask, how many questions, sort of like, is Cher a moose, could the system answer? The answer is going to be like 100 trillion. Or how many type questions, like, are seagulls also mooses ever? Basically, they're on the order of hundreds of millions of questions like that it can answer. But the way it answers them is by having simple Linnaean taxonomy and a statement about disjointness, namely two taxons which aren't related by specialization are going to be disjoint. And now with 10,001 rules instead of 100 million or 100 trillion, you can answer pretty much all those questions. So we're constantly looking for ways to keep the numbers of axioms as small as possible, not as large as possible. I don't have time to go through the content of the knowledge base, but it pretty much spans all the things you might imagine, like relations between things existing in time, or the kind of knowledge you'd need in order to conclude things like, in this case, Condoleezza Rice and Ariel Sharon must have been in Jerusalem for at least 3 days during February of 2005. Or different kinds of parts, like if you ask if the Sonora Desert is part of the sum of California, Arizona, and Mexico, there's an important sense in which the answer is yes, and the system should really give you a yes answer to that question. in terms of like representing physical containment, the notion of physically in, X being in Y. In 1984, we just had one predicate in, but slowly over time, that expanded because the way that you're in this room is different from the way the air molecules are in the room, which is different from the way that this dollar bill in my pocket is in the room, and so on, in terms of visibility, or what would happen if it were turned upside down, and so on. So eventually, over the years, we've had to add something like 75 different meanings of in to the system, and if you don't make those distinctions, then there are going to be questions that you just get wrong that you otherwise would get right if you make all those distinctions. 11,000 kinds of events, 400 roles that an actor can play in an event, information about emotions and what causes different emotions and so on. Lots of propositional attitudes, most of which are what you would call modals, believing, intending, desiring, hoping, expecting. And you need to be able to represent nested modals, like following the recent election, Israel's afraid that Egypt is going to want the U.S. to try to convince Iran, ... that sort of thing. If you can't represent statements like that, then again, they're going to be elements of everyday news, elements of human common sense that you simply are lacking. And so it's dangerous to have under-expressive languages. Lots of information about devices and so on. This is a diagram we've shown for about 20 years. The good news is that we're sort of at the end point of this. We talked about machine learning, where you learn more based on what you know already. But unfortunately, if you're way over here at the x-axis, you don't know that much, you can't learn that much. And a lot of our machine learning programs 20 years ago, 25 years ago, were stuck back near that origin. So it's very painful to use machine learning if you have to start out with essentially nothing, priming the knowledge pump, as it were. You could say, well, contrast that with learning by being told. Well, all those examples we saw, like the pen is in the box, make it very hard for the system to understand by being told, understand by reading things out on the web, unless it already has common sense. And yes, eventually you have to fall back on machine learning, but when you're way over at the left edge of the curve, both of these are sort of inferior to the sort of ugly duckling tactic of just manually writing down all the damn rules one after another. So this was like the really sad realization that we had in 1983. It's sad because there's not really a lot of science here. There's at most engineering to get that crossover point achieved. And as I said, it was almost 1,000 person years of effort to get there. We got there in 2004. So the last couple of years, we've mostly been moving from this mode of manually adding knowledge to the system to automatically adding knowledge through machine learning, through natural language understanding. It's a very exciting time for us. An example of what I mean by this is going out to the web and fishing. So for every organization, there are 100 things you want to know about the organization. When was it founded? Who are its leaders? Where's its headquarters? How does it get its money? And so on. And for each one of those, we can do natural language generation, generate alternate ways of saying those things in English, go out to the web and fish for those, and by gosh, you often find exactly what you're looking for somewhere on the web, because the web is really, really big. And there's a good chance that if you have a few alternate ways of saying it, someone would have said it that way somewhere. So you go out and you fish and you get information, and then you can add that to the knowledge base if you're courageous enough. Here's a case where we wanted to know the height of the Eiffel Tower. We went out and found it. And it turns out some of them that you find are wrong, but you can use common sense to decide in cases where there's a genuine disagreement, which is probably the right answer. By the way, in case you wonder where it got the 36 feet from, it's the very first hit returned by Google because it didn't quite parse the sentence correctly. But anyway, in a case like marital status, there aren't that many marital statuses. So for each one of them, you can do what we just said. And then you find out what the person's marital status was, and even better, what their marital status was at different points in time, and so on. Now, I said if you're courageous, because the problem is that, as we saw over and over again, a lot of the material out on the web is just wrong, just plain old wrong. It's fictional, it's a lie, it's metaphorical, it's for dramatic effect, it's someone's idiosyncratic belief, and so on. So basically, what we had to do was, by the way, this is like an example of, what parts of the body are hats worn on? Well, an awful lot of the hits out on the web don't actually say hat on his head because everybody knows that's where hats are worn. So they only say things that are cute or dramatic or whatever. So basically what we had to do was to find a way to vet or filter the 50% of the good stuff we were getting from the 50% of the bad stuff we were getting. So what we came up with was the idea of having a game. In some ways, this is the analog of what Louis van Aan has been doing at CMU with captioning images. In our case, what we do is we have people play this game, and they're asked, I think we can actually do this live. So here, the danger is that some of these questions may be a little bit weird, but that's okay. So now 10 people are somewhere in the world are simultaneously being asked this question. And so aisles generally do live longer than diaries, but maybe not that many people agree. And to an order of magnitude, how big is a motor scooter? I'm guessing it's about person-sized. That's probably true. And that's probably true, and so on. I'll stop this in a second, but you can see it's very addictive. And after you've answered this for a while, you get scores and you get points, and eventually you get to compete with other people and so on. So from the people point of view who are playing this, they're just playing a game. From our point of view, they're giving us free labor to disambiguate and vet information out there. So by now we've gotten something like 500,000 people playing this. And soon we'll have gotten to the point where more than half of the content of Cyc will have been put in through the sort of fishing and vetting process rather than the kind of cloistered philosophers, logicians, manually putting information in that we did for the first 20 years of the project. That's sort of an exciting statistic. I can skip through that. Okay, so we talked about this already. This is just basically making the point that if you talk to folks who work on like RDF or OWL or DAML or something like that, basically the problem is that not that they're making an error, just that they're believing that you can get by with just agreement on 10 or 20 or 30 different relations or types of attributes and so on. It's sort of like saying if you were translating Hamlet into any subset of English you wanted, where I'd let you use any 50 words you want. You could use all the proper nouns in Hamlet, plus 50 words that were not proper nouns. And you have to pick the 50 words and then translate the entire play using those 50 words. It's going to be a nightmare, and it's pretty much the same nightmare for exactly the same reason, namely that if you're not careful, you haven't made enough distinctions. And you just start getting a lot of questions wrong if you don't make enough distinctions. As I've sort of hinted, there's no actual correct ontology. It's very contextualized. So, if your spouse asks you to bring home some of those red flowers they like, and they mean poinsettias or something, and you show up without them, and they say, where are they? And you say, oh, it turns out poinsettias aren't actually flowers. Okay, that's like not in your best interest to do that. There's sort of like common sense ontology in which apes are monkeys and poinsettias are red flowers and so on. There are lots of different representations that are semantically equivalent to each other, and it's not like there's any one of these which is better than the other. It's not like there's any one of these which is correct. So you really need to make all these different distinctions and interrelate them by saying this is what the average American believes about, this is what the average 7-year-old believes about the world, this is what most adults in 1940 believed to be true about the world, and so on. So you need that kind of contextualization. And by now, every assertion in Cyc is contextualized to the context in which we believe it to be true. So if you say, is Dracula a vampire, most people would say yes. But if you'd also asked them, are there any vampires, they would have said no. It's that kind of contradiction if you're not careful. Or, like if it's raining, should you carry an umbrella? As people in Seattle know, the answer is well, actually in Seattle, probably people ignore the rain. But in most parts of the country, the answer is yes. But there are all sorts of exceptions, like if you're talking about non-humans or babies or people living before the invention of umbrellas or things like that. So basically, each assertion is contextualized using a kind of ist format like this. We have by now about a dozen different major ways in which one context can differ with another. I think I'll sort of skip some of this, but basically it's not obvious how you automatically conclude if P is true in one context and P implies Q is true in another context. How do you conclude exactly in what context Q should be asserted? Turns out to be a very complicated problem, and it's one that we're spending a lot of our theoretical time worrying about. In terms of the caveat emptor category of buyer beware, I'll sort of list here the 5 ways in which most people who claim they have semantic technologies are actually cutting corners. And to be fair, I'll say that we do some of all these things as well, but we do less than most people. So one of the problems is giving in to the temptation of being ignorance-based. By having fewer assertions, more of them are going to be relevant. A higher fraction are going to be relevant. In the extreme, if you only have 7 relevant pieces of information, and that's all you know, it's really easy to decide which 7 pieces of information to combine to get your answer. Static knowledge bases. If you're not careful, you end up with a system which is highly tuned for a static knowledge base, whereas in a lot of problems, like Eric was telling us yesterday about the traffic flow stuff that you're doing. The world is changing every few seconds or even every fraction of a second. And you can't have the luxury of taking a knowledge base and fixing it for a month and doing some kind of optimization on it. A third sort of pitfall of most semantic technologies is picking a representation language which is unexpressive, which is too simple. And you get efficiency that way, but you throw out part of the baby with the bathwater. If what you're doing is deciding what courses should go on in what classrooms at a university, simple SAT solvers might suffice. But if you're trying to do reasoning about courses of action in Iraq or something, it could be very dangerous to pick too unexpressive a representation language. The fourth one is somehow assuming that everything's going to globally fit together consistently. As we saw, there's the need to contextualize because things are true in one context and they're false in another. So the way our system works is basically to reason within a context and slowly do a kind of spreading activation farther and farther afield as it needs to. And that works because the knowledge base is locally consistent in much the same way that you live your life as though the Earth's surface were flat. Even though in your mind you know that it's a sphere, it doesn't matter because locally it is flat. And you can get by most of the time without worrying about the fact that it's spherical. In much the same way, our knowledge base, even though it's inconsistent, is locally consistent. We can get by acting that way. And then finally, the dangerous assumption that whatever you've been told and you've concluded, you can count on forever. Almost nothing has that property. There's no telling what you might find out tomorrow that would cause you to invalidate something that you were told today or some complicated consequence of something that you believe to be true today. So you really have to have kind of truth maintenance on all the time. The way that people use the system is generally to extend the ontology to add more terms, to extend the knowledge base to add new rules or assertions, and in rare cases, modify the heuristic level mechanisms, the reasoning modules, in rare cases modify the interfaces and so on. We've released the entire Cyc ontology for free for anybody to use, even for commercial purposes. You're more than welcome to make use of that. We also have released for research purposes the rest of Cyc, all the millions of rules that talk about those terms and so on. And we have a lot of people that are using Research Cyc by now. I made a list in 1984 of what I thought the winning applications for Cyc would be 20, 25 years in the future. Almost all of those I still agree with. And in terms of things you guys are doing here, some of the relevant ones are things like machine translation. because sometimes 90% accuracy or whatever it is you can get these days just isn't quite enough. Like if you have legal contracts where mistranslating a single pronoun reference is going to cause the meaning to shift of the contract or whatever. Or doing translations like these. Like if you want to translate into Japanese a sentence like, Mary filled the tea kettle with water. After it whistled, she poured the water into the cup. In Japanese, you need to use different words for cold water initially and hot water eventually. But how do you know the water starts out cold and ends up hot? Well, it's because of your knowledge of tea kettles and so on. Or speech understanding. Sometimes 95% or whatever you can get these days isn't just going to be enough. It might be in some narrow niche area, like bedside intake interviews with hospital patients or something. But in general, it's not quite enough across domains. And when I was helping to start Microsoft Research about 15 years ago, we actually started some speech understanding projects. And there was a lot of hope that we could get by without this kind of common sense knowledge. And I'm still waiting for the general domain-independent speech to emerge. Meanwhile, we've gotten the common sense stuff put in enough that we might be able to help with this problem. The two examples there, one was Alan Kay asked me how we were doing, and I said, good, I've hired 10 people last month. And he said, oh, that's terrible. And it took me a while to realize that he thought I said I fired, whereas in fact I said I've hired. If I had prefaced that with, we just got a big new contract, ... then he would have understood it the right way. Or back when Bell Telephone was Bell Telephone, they did some study on signal-to-noise ratios on scratchy phone lines. And they kept getting results that were above the theoretical maximum. Because people's brains are so good that they could actually correctly figure out what other people on the other end of the line were saying, even when there wasn't really even theoretically enough signal there to figure it out. In terms of things like Microsoft Word, spell checking, I'm sure as you've noticed, doesn't seem to be very context sensitive. Grammar checking and style checking sometimes hit, sometimes miss. The paperclip assistant has gotten better and better, but still sort of annoying in that it doesn't quite understand a lot of times what I'm asking. Then there's also possibilities like content checking. Like I say in this Microsoft Word document below, I'm going to talk about X, Y, and Z, and I never talk about Y. It would be nice to highlight the Y in some color until I either change that sentence or actually talk about topic Y somewhere in the article. In terms of things like spreadsheets or simple relational databases, there's all kinds of possibility for automatically understanding or semi-automatically understanding some of the meaning of the columns or the relations, and then using that knowledge, like we saw in the case of the hiring date and birth date and so on, to basically detect probably incorrect usage of a column or unstated relationships that constrain column values, or noticing even that we could guess at the value of a certain cell entry would be pretty cool. Summarization and prioritization of text, things like spam filtering. If I go on vacation, should this message that comes to me just wait for my return? Should it follow me on vacation? Should it go to the person who's now doing my job at that company while I'm on vacation, and so on. Noticing contradictions, like I just accepted 2 different appointments that I'm not going to be able to spatiotemporally get from this one to that one, even if they are 1 hour apart. You know, there's sort of more than a 1 hour commute between them, that kind of thing. And all that goes double for places where you don't have a lot of screen real estate, like if you're trying to quickly scan your voicemail messages from a phone. Shopping and matching up buyers and sellers, matching up people who have jobs to offer and who want jobs, matching up people who want to donate things, like you know, if it's really a children's hospital, they may not really want hockey sticks, even if they do want, you know, games and toys and other things that hockey sticks might be in the same category as, and so on. And so here's a case where we gave advice about tours, knowing things like this person was a nurse. Then a free day in Geneva was a plus because that's where the Red Cross Museum is. And knowing that someone had trouble walking, we sort of warned them about some tour that involved a lot of walking over uneven ground and so on. Games, especially massive multiplayer online role-playing games. There's all sorts of problems with NPC realism because, in fact, the NPCs don't have common sense. So if you ask them pretty much anything that wasn't preconceived, there's a good chance they're going to give you a bad answer, and there's a good chance their behavior is going to be pretty heavily scripted. And if you say, well, why do various MMORPGs come to an end? It's usually because the players come to the end of the content, and they get bored and they move on to some other new MMORPG that's come into being. But if, in fact, you had the same kind of common sense we've been talking about, you could begin to generate new content automatically, which is a really exciting thing. Anyway, to summarize all this, I want to bring this to a close and take a few questions. We talked about the need to pull information arithmetically and logically from multiple sources. We talked about breaking the software brittleness bottleneck by collecting large amounts of information, ontologizing it and axiomatizing it, using an expressive language, contextualizing it because things are true in one context and false in another, spending 20 years in the wilderness, priming the pump to the point where the system itself can act as its own inductive bias, can help with its own education by using what it knows about the world in order to sanity check and help human beings to fish for and vet information out there in the world and to help carry on conversations to gather new information. So let me stop at this point, take a few questions, and hope that you guys had fun in this talk. Thank you. Thanks. Yes?
So you gave an example of ways that it could improve search. Has it been applied to improve kind of general search for governments by the usual measures?
So the question was, has it actually been applied to improving general search? We did a project for Hotbot, and it got hooked in and actually went live for a month or so. Just about the time that that happened, Hotbot got bought by Lycos, and the process sort of started from scratch. Then after about a year, went live on Lycos. And about a month after that, Lycos got bought by Terra, which was a Spanish company. Terra decided that, what's all this about technology? We don't need technology. Lycos' success has nothing to do with technology. Let's get rid of all the researchers. Let's get rid of all the external R&D contracts and so on. I must say that I'm pleased. Well, I feel vindicated in the path that Lycos took after making that decision. But basically, just at the stage where it seemed to get used, it sort of got something kept it from getting deployed in a big way. So we've been talking with search engine companies about possibly doing something with this, but nothing much has happened in the last few years with that.
We have a late-breaking question from high-tech technology here, my cell phone, from our Silicon Valley lab.
Okay.
And it is, can Cyc build an ontology automatically from drifting through the web through a syntactic engine?
So that's a good question. And I would say that the answer is around the fringes, yes. And by that, what I mean is that to the extent that you're talking about extending and modifying and making a little bit more precise what it already knows, then the answer is yes. If you're talking about a whole new domain where in some sense all the terms are strange to it and so on, then it would generally not be able to do that. If you think of it as a step-by-step extension of what it knows already, then yes. But in terms of just trying to make sense out of a massive text about some domain that it has no idea what it's seeing or how it relates to everything it knows already, then I would say no. It's just not going to be very good at that.
John?
On the Cyc game,
Yes, there are a lot. We haven't noticed bots playing it, but we have noticed bad behavior by humans. So we had to go to a scheme where we intentionally negated half of the things that we asked people, so that you couldn't just answer yes all the time and match a large number of other people and so on. We have noted that some people are much more reliable than others. And so even though we continue to let everybody play, we weight the results more heavily by some players than other players based on their track record of how often they've been right. And eventually we want to learn enough statistically that we can decide that this particular person is very good at these kinds of questions or this domain of questions and not so good at these others. But we haven't hooked that in yet, but I'd like to. Yes?
How long do people tend to play the game?
Enormous variance. A lot of people play for 10 to 30 minutes and they never play again. There's some people who've played so much that I feel guilty as contributing to some sort of whatever problem they have. We've been feeding it or something like that. So some people have actually put in hundreds of thousands of answers, which is I find frightening. Yes.
What is the methodology by which you're picking the challenges to get human feedback on?
Oh, we read through the web, and that's the wrong way to put it. We basically have a large number of concepts which are partially fleshed out. Many of them are proper nouns now, like organizations and individual human beings and named events and so on. And some of them are more generic things, like a new kind of disease comes on the market or a new drug comes on the market or something like that. So now what you do is for the type of thing, you look up the 100 things you'd like to know about that type of thing. That type, if it's a person or an organization, a type of drug, whatever it happens to be. Now for each one of those attributes, we do natural language generation, which is vastly easier than natural language understanding. So we do natural language generation using the lexicon we have and the grammar we have and so on to produce sort of fill-in-the-blank English strings that would be stating the piece of information if we could find this out on the web. And then we call on the appropriate search engine, which for obscure reasons generally turns out to be Alta Vista, just because of the what they allow us to do compared to what Google allows us to do, and so it doesn't really matter. But anyway, so we call on the appropriate search engine and we get the matching strings back, and to the extent that there is general agreement, then we have a candidate assertion for testing, but we don't just believe it. It becomes something which now feeds the pipeline of this web game, so that if 10 people are now asked questions whose answers sort of trivially depend on this being true, and by which we're going to be restating it in many different ways, so it's not like the sentence that happened to be out there is just handed to the human beings. If we rephrase it based on the predicate calculus that we have, we generate natural language from it, usually very, very unlike whatever it was that came in from the web. Now, if like 9 out of 10 people say yes to this or whatever it happens to be, then we'll believe it and add it to the knowledge base. And it occurs to me that I'm throwing around these vague statistics like 9 out of 10 and so on to like the one person in the audience I should like think twice about doing it to. But I'll move slowly, I'll edge slowly away from you and take another question.
I do think that's a qualitative statement, not as a quantitative statement, that coming up with the correct or a well-founded algorithm for actually choosing questions to ask about for human mediation on would be very interesting task.
So in the case of a lot of these, what we have in the domain-dependent case, we've asked experts. Like in the case for intelligence analysis, we've asked intelligence analysts, if you're finding out about a new terrorist event, what are the 50 or 100 things you most want to know about it? Or if it's a new terrorist group you've never heard of before, what are the 100 things you most want to know about it, and so on. So that basically defines our space. And for a lot of the more well-known everyday kinds of things like piece of furniture or type of communications device and so on, we ourselves are enough of the domain experts to make up our list of 50 or 100 things we want to know about that. Oh, and there's a kind of belief in incremental correction, namely, if we're wrong, then eventually we'll find that we have to keep manually adding something that we should have been getting automatically, and that'll get added to the list of things that we try and fish for automatically. Yeah, Lucy.
So I guess I always have a question about your use of the term common sense in this context, because especially when you describe the fishing, it seems what you're going to be fishing for are facts rather than common sense.
Oh, absolutely.
I'd like to make a distinction between dictionary knowledge, which is about the lexicon itself, and then there's factual knowledge, and then there's common sense knowledge. And of the fishing you do, kind of what is the type of knowledge that you are actually acquiring using the phishing? And then, if you're vetting using factory only the factual knowledge, are you kind of getting more common sense knowledge, which I think you still need?
Okay, so that's an interesting point, and I'm going to have to think about, not in real time, but I'm going to have to think about why it is that we don't vet common sense knowledge. Okay, so I thought about it, despite the fact that I didn't want to in real time. It's very hard to explain to people. It's very hard to generate comprehensible to the average person sentences at the high levels of our ontology, which is really where common sense attaches to things that are related to like physical objects in general or things that exist in time in general or something. That if you look at the sentences that we would generate about that, the average person would say, what are you talking about here? And so even though the average person knows the answer, if we could only explain the question, it's very, very hard to explain the question. So by and large, there's a smaller quantity of such stuff. We've already dealt with that manually. We're already moderately happy with what we have. And it is the vast plethora of domain-dependent information, much of which is factual and is domain-dependent details and so on, that we don't have, that we will never have the manpower to do manually, that we have to do automatically, that we have to do by phishing. It's the final 99.99% or whatever of the knowledge base that has to be done this way, and it's the common sense part that we've done manually over the last 20 years that we're relatively happy with. That doesn't mean that I wouldn't also be willing to have volunteers vet and correct and extend the common sense knowledge, but I think we'd have to have a different way of doing it, a kind of almost a non-linguistic way of doing it by giving them sort of problems to solve, and that would require this piece of knowledge being true or this other piece of knowledge being true, and not try to explicitly communicate and ask them that question.
So then, when you're fishing for the specific data facts, how is it different what you're doing from know-it-all? And how, in fact, do you tie it to the concepts? Because what you're fishing is English. And you've made a point that you don't want to encode that knowledge in English.
Superficially, it doesn't look that different from know-it-all. The difference is that we've generated this sort of fill-in-the-blank template in the form that if we can find, for example, this pattern exactly with a number right here, then we could take that number and assert it to be the height in meters of a certain building or something like that. So we've basically generated this in a form where we know the exact predicate calculus representation for what the meaning of this utterance will be if we can find it with a single variable here, which would have to get filled in the text. So it's a very subtle distinction, and in terms of the way it looks to sort of someone watching it work, would be almost indistinguishable from know-it-all. Other questions? Yes.
I'm trying to understand one thing, and I'm not sure exactly how to explain what it is that I'm trying to understand. So if I think about how humans gain a lot of their knowledge, often we find ourselves suddenly dimly aware that I have some cognitive dissonance about something. Something just isn't making sense. So something that I've added to my database of beliefs about to be questioned, and I don't know quite yet, and I have this kind of internal search algorithm, and then eventually I figure out, oh, this thing is actually wrong. So when you add things to your knowledge base, is it always cumulative, or can you go not at all modality that you can add to something, or maybe a context level?
So I look forward to the day when the kinds of phenomena that you're talking about are what we're sort of grappling with. Right now we're grappling with almost the uninteresting element, the uninteresting component of like something that people know. It's not really controversial. The system just doesn't happen to know it yet. And if it doesn't know it, it's going to get a whole bunch of things wrong in the future. And it's not the kind of sophisticated sort of process that you're talking about. I'd love to be working on that kind of process that involves illumination and incubation and intuition and inspiration, and all the things that Poincaré talked about. All that it's like, yes, that's how I got into this. Was originally trying to get machines to do that kind of discovery, as Eric mentioned in his introduction. And it was only a kind of a 20-year detour that caused me to do this because nobody else was doing it. But I would love to get back to work in exactly that kind of automated learning.
So let me scope that question down for a moment. What if somebody made a mistake while entering basic common sense data? And as a programmer, I often find that something that made absolute sense to me turns out to be dead wrong.
Oh, sure. We believe that approximately 1% of what's in Cyc is wrong. And what happens is this kind of incremental detection and elimination process where at the moment we have this conceit that it's all correct. And to the extent that that's wrong, and we know it's wrong, wrong answers will occasionally come out. So a wrong answer comes out, somebody says that's the wrong answer, or they try it out and it doesn't work, or whatever. So now that you know that's the wrong answer, you go back to the justification. You identify what the culprit was, you remove it, correct it, contextualize it. Usually it turns out it just needs to be contextualized. Like if the person who put this in wasn't actually being intentionally disruptive, they didn't properly contextualize what they said or something. So now you fixed it up, and incrementally the system's gotten a little bit better, and so slowly, incrementally, it gets more and more accurate. In a way, that's, I think, what happens with us, which is some fraction of what we believe to be true about the world we're just wrong about. And for some of these things, we may go through our whole lives and never realize that we're wrong about this. And, it just doesn't matter.
Heaven and hell, that was wrong.
Well, that would be... Right. So some of them, the stakes are higher than others, but still, you just go through your, and so if you go through your whole life, or Cyc goes through its whole life, and it doesn't matter that this piece of information was wrong or something, then what does it really matter? And if it does make a difference, then presumably it will lead to bad behavior, which will get corrected in this incremental fashion. So hopefully that will either make you feel a lot better or a lot worse. I don't know which, but that's what we end up having to do because there's just too much material for it to be absolutely correct all the time.
Kevin?
Should we take one last question?
Yeah,
okay.
Were you expecting it to take 20 years to program in common sense, and how do you know you're done now?
No, I expected that it would take somewhere in the order of 10 years. And due to a large number of errors canceling each other out, we were only off by a factor of 2. So basically, there's much more that had to be put in than I expected. But we're also able to put it in a lot faster than I expected, but not, unfortunately, exactly as fast. So the way I know that we're reaching a kind of crossover or closure point is that the ontology is changing less and less often. The upper ontology almost never has to change anymore. We could put in the entire contents of USA Today and not have to add any general concepts at all, just add some new proper nouns to the system and so on. So there's a kind of slowing down of the ontology expansion and re-engineering process, which used to happen very often, now almost never happens, except at the very, very, very bottom levels where you have domain-dependent information. The second thing is that we have enough knowledge in the system to power this kind of automated phishing system. The NLG behind it, natural language generation behind it, and the disambiguation when you get seemingly disparate answers coming back, like the 36 feet and the 980 feet for the height of the Eiffel Tower and so on. That the knowledge of human buildings and human scale objects and so on is enough to disambiguate a lot of those things. And so it's a combination of the slowdown of some things and the speed up of some other things that cause us to believe that. And in a way, we're putting our money where our mouth is in that the fraction of employees that we have who are doing the sort of manual knowledge entry has shrunk from about 90% to about 5% in the last few years. Almost all of the people we have employed today are linguists, are machine learning folks, not knowledge enterers, not logicians, not ontologists.
So I'd like to ask you another question. I could give your answer just now. So that's the first time I heard you say that you thought it would take 10 and it took only 20, which suggests closure and...
To get to the crossover point.
The crossover point. And how do you define that?
The crossover point is the sort of tipping point where we basically can shift most of the activity going on a day-to-day basis in most of the offices at Cycor from manual knowledge entry to working on NLU and ML and so on.
Well, thanks very much.
Thank you.